I'm I'm really glad to be here, and I'm looking forward how this turns out and how we can learn something out of this.
We are looking forward to it as well, ma'am.
Okay. So, should I begin with this? I'll start presenting.
Yeah. I think we can begin and the students will keep on joining in.
Okay, let me know if you have to wait for a few more minutes. We can wait maybe 2 more minutes till
Okay.
35. Okay.
Yes. Yes. I think we should start and maybe participants will keep joining in.
I'll start sharing my screen. I hope you are all able to see my screen. If I isn't able to, just let me know.
It's visible.
Okay, cool. Okay, so hello everyone. I am Simran Gambani, and I am a 2019 IT graduate from SPIT. And currently, it's been 1.5 years since I've been working with JP Morgan Chase as a software engineer. So thanks a lot for having me, and I am very excited to share some concepts with you all, and also know how you all are going through, and hear your questions and answer any of your doubts that you have regarding placement preparation, interview preparation, and in general from where to prepare competitive programming or interview problems and so on. Uh, so today in the next 1 to 1.5 hours, will mostly explore and touch base some graph concepts. I'll be mostly talking about things like recursion, backtracking, how they help solve a lot of graph problems, and I won't be talking in very strict technical terms. So we will try to see a bigger picture as to how to approach any problem, visualize the problem, focus more on that, and then also walk through a code. And then I can also take up any questions regarding interview placement prep. I'll share some of the things that I do to keep in touch with interview questions, and what helped me back then while taking up job. And further on, you can ask me anything. And also, Also, you can like be free to speak up anytime. Mute yourself. Just ask me to pause if I'm going too deep into something or if you're not understanding. Just let me know. I'll stop and I'll recap it. So don't keep your doubts to yourself. If you're not understanding, just let me know. I'll stop there. And we have. I have thought of covering like two problems. It is okay if you're not able to like go through and through both of them, as long as whatever we cover, you're able to get that. So just let me know. Okay. So I think we can begin now. Fine. Uh, so our main topic to explore today would revolve basically around this data structure graph. So we have many data structures. We have linear data structures like arrays, linked lists, and graph. Whereas is not okay. I forgot something. Before I start, can I know the number of people who are in first year, second year, and third year? I'll just call out, and if you can maybe say hi or turn on your mic so I can know like what is I can gauge my audience. Can I know how many of you are in first year? So I'm copying from chat. Others can too. Okay. First year, second year, one from third year, Vibha is first year, Ria first year, first and second year. I see many first and second years. Okay, so you must have like just completed first year. So nice. Okay. So considering like you are first year, second year, third year students, you will be like at the beginning of the learning stage, getting into all these data structure and algorithms. And I would say you should really pick it up from your first year itself. Like do it bit by bit rather than ending up in third year and then rushing over it in 2 or 3 months. That is also okay, but if you keep in touch with it throughout all your years, that would really help and reflect later on. So, okay, I'll try to keep it as simple as possible. Still, wherever you think like I'm going too far or too technical or too deep, just let me know if you're not understanding anything. So I'll continue. Uh, yes. So the data structure graph is a non-linear data structure and it consists of nodes and edges. So there is a reason why graphs are so popular as questions in software programming and in interviews. That is because they have wide, huge application and they can solve many real life problems. So in even when you start working, you can see that there are a lot of concepts that can solve using graphs. So I'll talk about like two real world problems that can be solved using graphs. So oftentimes, what if you need to decide which other flight route to add between the cities to make that particular state and that particular country's connectivity better? Graph can help here. Graph can help you find out the most connected cities or where a connection is missing. All of these are actually concepts of graph which you will come across and as and when you delve into the concept of graph. Then there's another concept like you can say you have a network of computers. All of them are connected with wires and cables, and it is necessary for that whole network to be up only if all the computers in your network are connected to each other. What if you want to find out if I remove this particular cable from between computer A and B, how will that affect my whole setup? Will it go down? Will it still keep functioning? Again, over here, graph helps. Again, here the concept of missing connections, the most critical connections comes in. These are some very vague but very real world problems which can be solved with using concepts of graph. So graph is actually very vast. There's a whole subject regarding it, graph theory, which delves into many different topics like strongly connected components, Dfs, Bfs, cycle detection, uh, whether the graph is directed or undirected, in degrees of nodes in a graph, topological sort. These are all concepts that you will come across when you delve deeper into graphs and solve more of its problems. But for today, the three main concepts that we'll touch base on and do some basic problem solving on will revolve around these three concepts of graph, that is DFS, depth first search, recursion, and backtracking. So for background, DFS, depth first search, is kind of a, you can say it's a traversal strategy and a search strategy for any graph. And recursion and backtracking are very basic uh, programming concepts, which I'll be talking on more and explaining further. What is a graph actually? It looks like this. It's a nonlinear data structure consisting of nodes and edges. Here you can see A, B, C, D, E are the nodes, and the connections between these nodes are called edges. Uh, Another main concept that comes into graph is this is a node. What are the nodes around it called? The nodes around it are very important because if you want to move across the graph, if you want to search across the graph, if you want to go from A to E, you have to cross nodes. This is where the concept of neighbors comes in. So all of your nodes in a graph will have neighbors. Neighbors mean the immediate connections that a node has. For example, here if you see A has three immediate connections, B, D, C. Even though it can reach E, that is also technically a neighbor of it, but it's a far off neighbor, not an immediate neighbor. It has to cross another node between it and doesn't have a direct connection. So if you're asked to say that what are the neighbors of A, it's B, C, and D. So these are three main things that you will have to remember. Nodes in a graph, the edges that exist between the nodes, and the neighbors of each node. Now, graph can be of two types. It can be undirected and also directed. So, undirected means that your path, the edge between any two nodes is actually bidirectional. As in, if you are suppose at node 0 in this graph, you can go to node 1 and also go back to node 0. This is a bidirectional connection that is in undirected graphs, and it doesn't specify like from 0 you can only move to 1. You can move back and forth from it. Whereas in directed graphs, you your edge has a arrow which points from the start to the end of the edge. That is, this particular edge starts from node 0 and ends at 1. You cannot go back from 1 to 0 unless you have a directed edge showing from it. Just like you in between 0 and 2. Yes, you can move from 0 to 2 and again back to 0 because you have a directed edge here. Unlike here in graph 1, which is undirected, this means that it's bidirectional. This is another concept apart from nodes, neighbors, and edges to consider that whether the graph is directed or undirected. I'll pause for a moment here. Anyone wants to interrupt any doubt, or you are on the same page as me? Okay, I take this as yes. If anything, just bring it on the chat, and I'll stop right there. So till now we saw nodes of graph, what are the edges of graph, what are neighbors of any node in a graph, and whether the graph is directed or undirected. For simplicity's sake, today we'll consider only undirected graphs, whereas like in undirected graphs, you have connections moving back and forth, which are bidirectional. Mm, Okay, so you can see in the graph, this is what it looks like in real life in any diagrams or any visualization. But how do you represent it in code? You have to represent it in using some data structure which you can use to operate on and manipulate it. Because if you have some problem like you have to search a node in the graph or you have to traverse the graph, you have to move across the graph, you need to have some representation of graph in your code. So there are two main ways to do that. One is the adjacency matrix and the other is adjacency list. Adjacency means nothing but uh, the adjacent nodes of a node. That is again the neighbors. Adjacency matrix is for example, if your graph has 5 nodes, your adjacency matrix size would be 5 into 5. And in this adjacency matrix, you will be denoting the nodes and the edges which connect between the two nodes with with a sign as 1, and those which do not have any connection between them, you will mark it as 0, so that you know which path you can go forward to. For example, in this particular graph, you can see A has neighbors B, C, and D. So this is where A has connections to B, C, and D. That is what you represent as 1. Whereas A does not connect to itself, A does not connect to E. Those connections are seen as 0 in the matrix. Similarly, if you check for node D, D connects to all of them, A, B, E, and C. So D has connection to A, B, C, and E. All of these, A and D is represented as 1. B and D edge is again represented as 1. C and D edge is again represented as 1. D doesn't have a connection to itself, so it's represented as 0. So this is how you fill a adjacency matrix and represent it in the code. The other way to represent graph in code is using adjacency list. Actually, this is the most popular, or maybe you can say this is the easier way to represent it in if you face any competitive programming problem or any interview question. So adjacency list is very widely used in that case. This is again a map. It's a map of a particular node and its neighbors. So, for example, we have this particular graph and its neighbors are B, C, and D. The map will consist of A and its neighbors B, C, and D. So, if you are asked what are the neighbors of A, you directly have a key to value connection. From the map itself, you can see that the neighbors are B, C, and D. These are two ways of representing graph in code. Uh, these again, as you saw, they revolve a lot around node and its neighbors. I hope these representations are clear. We won't really be using them right now, but as a concept, it's important, and you'll in many of the problems, in many of the competitive programming problems, making these representations is one of the first steps. Um, so these are the graph representations in code. I again pause. If you have any questions, you can just let me know. If not, we can move to the next concept. So we have a graph, suppose. What do we do about it? The main problems that you will face in any interview or in CP will be to search across the graph or to find the minimum path, find the maximum path, or or to find the edges that lie between two nodes. All of these problems require you to traverse through the graph, to move through the graph and search each node and check for its neighbors and go ahead. So most of the problems that you face would be searching and traversing of graph. This is where concept of BFS and DFS comes into picture. BFS is breadth first and DFS is depth first search. These are both, for now you can say they are searching strategies and traversal strategies of any graph. So before I say anything, I'll show you a visualization of how this BFS and DFS works. I have changed tab. I hope you all are able to see it. Okay. So this is a very good animation kind of, which has this particular graph. Zero is the source, and like it visualizes how the graph traverses using these two different strategies. One is BFS, the other is TFS. So it shows through the graph how it traverses through each of its neighbors. So before we see the visualization, very basic idea and the difference between DFS and BFS is that BFS tries to iterate, tries to move over all nodes of it, all neighbors of a node first. For example, this particular node is a source and it has neighbors 1 and 4. So what BFS does is that it moves over 1 and 4 first. Whereas in case of DFS, it picks one neighbor, processes the next particular neighbors, and goes on, repeats this process further. So in case of DFS, if you are at node 0, you have two neighbors, option of two neighbors, 1 and 4. You will move to 1 first, and then you will again try to find out the neighbors of this particular one. So it is called depth first because you go by depth. You try to go move to the end of the path, come back to it, and try to search another path. In that case, you have to go from find one neighbor, then find neighbor of this neighbor, and so on. So there's a repetition here. I'll first show BFS. Here you can see it starts at 0. It moves to its first neighbor and the second neighbor. 0 has two neighbors, 1 and 4. It picks the first neighbor, 1. 1 has three neighbors, 0, 2, and 5, which it traverses and searches across. Now it will consider the second neighbor of 0, which is 4, and try to traverse all the neighbors of this node 4. Now it goes to the neighbors of 1. It will iterate across its neighbors. It will consider its next neighbor and so on. So I hope you understood what is breadth first search. That is, You pick one node and you have to process all its neighbors. Only then you can pick another node from among these neighbors. 11 will now iterate through all its neighbors. This is how it traverses through across all the graph. Now let's see what depth first search does. I'll again start with the source 0. 0 has two neighbors again, 1 and 4. It chooses 1. Now it will process neighbors of 1, 2, 5, 6. It will pick first neighbor of 1 and process neighbors of this 2. At 2, it will pick the first neighbor of 2, process neighbors of 3 now. Here it picks neighbors of 7, processes all its neighbors, and so on. So this here you saw how it is going by depth, how it is first reaching the end of it, and only then it will go back to the source and consider its other neighbors if they are not yet visited. So I hope this visualization helped you point out the difference between BFS and DFS. Okay. Um, I'm just, I just, I just ping the link over here on chat if you all want to check it once. Okay. So, like we saw, for BFS, remember that it will process all the neighbors of a node first. In case of DFS, it will pick one neighbor and go on to process the neighbor of this particular neighbor and so on. So here we saw that DFS has a repetition in it. DFS, once it picks one neighbor, again it tries to do the same process that it did for the earlier node. Again, it tries to find out what all its neighbors are and then pick one out of it and so on. So this repetition here is what uh, in normal code, how would you handle this particular repetition? Can anyone tell me? In any general code, if you want to do the same thing again and again, what concept do you use? Anyone? Yeah, I think Ria wrote something. You loop over it. You iterate over it. You iterate over the same thing, and you do the same thing over it again and again. The another counterpart of loops of iteration is using recursion. Recursion basically means that you call the same function again and again because that particular function is anyways going to do the same thing for you. So why to write it or why to loop over it? You so looping and recursion is same in the sense that only difference is looping is where you have to handle the memory. Whereas in case of recursion, it happens in the background. In case of recursion, all your looping happens over a stack. For example, you want to recursively print the letters of string A, B, C, D. And you have one print function which you're calling again and again. That one way is that you put a for loop over that string and print A, B, C, D. Another way is to use recursion, call the same print function again and again. Only difference is that it will handle it in the background. The looping will happen in the background using a stack. So this is where repetition comes into picture, and that is where in any problem, in any graph problem which you solve using DFS, you'll see a lot of recursion because we just now saw what is the repetition that DFS uses to pick neighbors one and one again, because it does not uh, act like BFS, like trying to process all the neighbors of node first. It tries to pick node, pick its first neighbor, then go over to this neighbor and pick out its other neighbors. That's a repetition there, which you can handle using recursion. So we will see how this is done. I hope things are somewhat clear by now, and you have some basic idea about what graph is. Even if not, this is a problem which is like very logic based, so we'll speak of it in that terms. But this is a problem which uses um, graph DFS with recursion for its solving. I found this problem on CodeChef also. I found this problem on LeetCode also. I'll just go to the problem statement. So suppose the problem is that you are given a grid as input that contains ones and zeros. Your ones represent the land and zero represents the water. You have to count the number of islands that are formed with the ones and not consider the zeros because they are water. Uh, this is a wider grid. Consider this particular grid. And if you see that this is a continuation of, there are four ones together here. So this is all land here, and this forms one island, and there's water around it. I hope you are able to see all this. And um, can anyone give it a try? Like, can anyone suggest what can be done here? Havik says number of connected components in a grid. Okay. Yes, we will have to find the number of connected components. Hmm. Bhavik, if you know, can you expand on it as in how we will try to find it using concepts of TFS or recursion, or do you have any other approach? We will run DFS from any unvisited node. Right. Okay. Okay. So Bhavik says that we will run DFS from any unvisited node and mark every other node as visited and count the number of times we have done DFS. Okay, that is one way to do it. So I'll just walk through how we can solve it. Again, over here, if I'm going too deep into it or you're not understanding any step, please let me know. So that grid again here is a matrix as a matrix of m into n, m rows and n columns. So what you have to do, as Bhavik said, that uh, first of all, this particular problem in the first go we don't really, it doesn't click to us that we have to use graphs here unless we are familiar with things like connected components or if we can use recursion or something. So so first of all, uh, Most of the times when you're given a matrix, things like where you have to find, you have to traverse through it and find connected components, number of islands, or you have to do flood fill. All of these relate to graph, relate to DFS, and relate to recursion. So suppose you have any grid, you have to run DFS over it, over any node. You can consider each component of the matrix as being an unvisited node, and you can consider it to be a node which you have to visit, which you have to traverse. Each node will again have its neighbors. So here we can consider the neighbor positions to be four: up, down, left, and right. So suppose we have a node at position I, j. In order to run DFS, we have to run it in four directions. So as to check, do I have more land left or do I have water? If I have water, you don't have to step on it. You have to stop there because that is where your component, that is where your land ends. So anywhere where there's land, in this case, anywhere where in your matrix there's one, you have to traverse that and in these four directions. So this is basically what I've done is I comma j. This is up down left right using coordinates of the matrix I and j. I hope this is clear to you all. So I will begin with the run. So one suggestion from you all: do you want to directly jump onto the code or do you want to do a run of the problem using the matrix itself? Any suggestions? Or I can first run through the problem once. Okay.
Simran, can you please explain the problem once again?
Yeah. Okay. So you are given a grid m into n of size m into n. This grid contains only two numbers, ones and zeros. Ones represents the land and zero represents water. You have to find out the number of islands in this particular grid. So like I said, in this particular grid, if you see, uh, suppose this is a matrix and you start from 0, comma 0, that is the first element. Here if you see that this particular one, the one at position 0, comma 0 is surrounded by land, and this particular, these four components are connected and they form one land, one island. They are all surrounded by water. So again, the catch here is that you don't have to consider lands that are diagonally connected. You have to only consider lands which are up, down, up, down, right, and left. You can't connect an island diagonally. So this one cannot be considered in these four ones island. Uh, Tanmay, is it clear now
Yes,
what
yes,
you have
yes,
to do? Okay.
yes.
Okay. So we do a run of the problem. I start. So this red represents the node that I am on. I start with 0, comma 0. Here I see that there is land, and now I will mark it as visited. In this case, you have to make sure that once you have counted the land for the islands, you have to flip it to 0. That means you have to sync that particular land so that you don't count it again. Okay. So once I have in normal cases, what you do is that if you have any particular graph, you consider an array of visited nodes. And as and when initially you initialize the array as being uh, as as none of the nodes being visited, as and when you visit each node, you mark it as true. You mark that node to be visited. In this case, we are doing a similar concept of that here, that once we have visited a particular island, one particular land, we are marking it zero. We are syncing it so that we don't count it again in case of counting the number of connected components. So I'm at one. I find that yes, that particular node has land, and I mark it as visited. I mark it as zero. Now I have over here. I have two options to go. One is for this particular one. That becomes my next node to check. And the other option I have is on the right of it that I can go. So these two nodes kind of act as neighbor of the first node, which I need to check. But here we have to do DFS because we have to exhaust all the approach, exhaust all the paths to find the number of components. Here if we here suppose if we go on to do BFS, what happens here is that we count the number of adjacent nodes. We count we count that it's connected to this particular node, and actually this problem can also be solved with the BFS. But in case of BFS, you would not need recursion because BFS has a repetition which can be solved using iterations, whereas DFS has such kind of repetition wherein you can call the same function itself and let it handle the recursion for you. So over here we consider the node that is below it and to the right of it. And first we go to the node that is below it.
Hi Simran.
Yeah, Nimish.
Yes, like earlier you said that the diagonal element is also a direct neighbor. So why here we are only considering the vertical and the horizontal nodes?
So your diagonal is a neighbor, but in case of the problem constraint, the connected components are supposed to be only left, right, up, and down. So that is why we don't consider the diagonal elements.
Okay, okay. Thank you.
Okay. So in my next step, here I was at node 0, comma 0. I move on down. That is the next row. That is my row becomes plus 1. My row becomes 1 and my column is still 0. This represents the node that I'm visiting right now, and this red bordered grid represents the node that I have come from. That is, this particular node that I am now currently is a neighbor of node which I already visited and marked as visited. So this is where again my condition satisfies that yes, there is land, and I mark it as 0. I sync it so that I don't count it again. Now I am at this particular node. I am at node 1, comma 0. Again, here I have three options to see. I can go up, down, and to the right of it. Now, uh, you can, so it depends on how you define the directions in the code. For example, here that I had shown, from I to J, you can go first to the next row, then back to the previous row, then to the right of its right column, and to the left of it. So over here, I'm considering that I'm always considering the next row of it. I'm considering the next ith element of it. Here I move on to the next node, and but here I see that there's no land. It's water, so I don't need to count it, and I don't have to um, consider it or flip it to 1 or 0, the water stays as it is. So what do I do now? I have to backtrack back to the place where I still have other possibilities to check. As I said, when I'm at this particular node, I have my up, down, and my right nodes to go. Once I checked this particular node, I see that there's still water there, and I need to backtrack to check if there's land across any of its remaining possibilities. So now I backtrack it. This orange signifies I have come back to the caller, come back to the recursion call that called me. Again, when I'm here, I see that it is already visited. This is the reason when we backtrack it, because we have already visited one particular land, we don't have to count it again. And that is where this is why we need to sync it so that when we backtrack, we don't count it again as one of our connected component. This does not meet the requirement. Again, it returns back to the caller from which it had come. It goes back here. Our initial caller was 0, 0, which had considered its below node and the node right to it. So the below node we have visited, we have seen that there's water ahead of it. We came back to this node, and now we need to consider the other nodes across it. Here, now this is where we do a here we have again three options left. We considered this option already, and now we can consider the option right to it, the right node over it, which satisfies that it has land, and here we again sync it. So this is how the code run is supposed to be. I think it was a bit confusing for you all, so I'll jump into the code and show how it's handled there. So we had the grid of ones and zeros. We have to iterate to over the grid because, as I said, that you can have the matrix representation of it or an adjacency list, but here the graph was already given to us as a matrix, so we can directly iterate over it and check, like Bhavik had earlier pointed out. We will run DFS from any of the unvisited nodes. Here, the condition that we have to see is that do we have land at any of the node? We need to check if we have land. If we have found land, we have to go on and find more land around it. That is where DFS comes into picture. We run the DFS over the grid, and here, so in case of recursion, the most important thing is that you have to find an exit condition for that recursion. So you recurse over, for example, you recurse over this particular, you recurse over this particular grid. You consider 1, you consider again 1, you consider 0, you consider 0. What if you reached end of it? So this is how you need to define the exit condition. Here the exit condition is what if you fall out of the matrix. That means what if the number of rows that you are traversing is greater than the number of rows that are given to you. You traverse first row, second row, third row, fourth row. You go on to traverse fifth row, but fifth is not within the bounds of the rows that are given to you. It's greater than 4. So that is how we have marked the condition here. What if the row that I'm checking is greater than the grid length? And the same thing for the column. What if I am checking for the sixth column, whereas we have only five columns in the grid? So this is the exit condition that we check, and we also check that whether since we have to only consider the lands, we have to only count the lands. We consider only the uh, nodes which are one. And if they are not one, you have to return back to the caller. So once you have found land, once you have found land here, suppose our first was 0, comma 0, you move here, you, you move that land to 0, you sync it so that it is not considered again in the count for islands. And next, this is where you continue with your recursion. Now you have to check for that particular node, you have to check, is there land above it? Is there land below it? Is there land to the right of it? And is there land to the left of it? All of this, you can, to simplify it, you can loop over it, you can iterate over it. But if you want to ask recursion to handle it, this is how you do it. Because once you have considered one node, and if you have to do the same thing for that, for the next particular node, for the neighbor of that particular node, you can call the same function. So once we have considered 0, comma 0, we check for the next node, that is a node below it. So that is how recursion is done here. And using recursion, you you can find all the components which form an island, and at the end you will have, once you're in this case, as we saw, if you have counted all these four ones, you would have left all zeros across around it, like here. Since I changed all of these are the ones, these are the lands that we had found, and we have marked those as visited. We only have now water remaining around it. So this counts as one of our islands. And this goes back here and increments the count of islands. Now we check, go on to check with the next, like the normal iteration of matrix that we do. So this was one problem which uses the concept of DFS recursion backtracking a lot. Um, I hope this is clear to you. Anywhere you want me to repeat or go back over it, or any doubts or any more discussions we can do on this particular problem, or you're not clear with the code or anything. Mm, feel free to tell me if you've not understood it. We can go through the run again. Okay. Okay. So this was one example of a problem which uses DFS, recursion, and backtracking. Maybe I would encourage you all to just try this problem once. This is there on CodeChef, this is there on LeetCode, and it's a very, like this particular problem I've seen in online assessments of quite a few companies interview rounds. So here in this example, as we saw, we had to do. Why do you think we had to do backtracking? Can anyone suggest why did we have to go back to a node in any case? So for example, like I was here, I found out that this is not land. But since I was called from this particular caller and I still had its right and above nodes to still be checked, that is why we had to backtrack. Okay, so backtracking is basically used to search through every possible combination in order to solve the whole problem. In this DFS problem, we saw that um, we had the option to check for land above us, below us, right of us, or left of us. That is, in order to check all the neighbors of this particular node, we had to backtrack each time we found that, okay, here my condition is not being met. So maybe I should backtrack and check for another node, another neighbor of this particular node if it satisfies a particular condition. This is how you make sure that you are trying to like exhaust all possible combinations, exhaust all neighbors of the nodes, all the path through the neighbors of the nodes, and this is where backtracking helps in your DFS problems. So many times another problem that I am reminded of that requires backtracking is what you are asked to find. You are given three numbers and you are asked to find permutation of this these three numbers. For example, you have 1 2 3 given, and how can you rearrange the numbers to create different permutations? You can rearrange it as 3 to 1 or 2 1 3. This, you would say that maybe again you can use loop and solve it, but to be honest, this is again a graph problem. Permutations is again a graph problem which uses DFS and backtracking to try and find, if you've considered, like, you have 1 2 3, if you've considered 1, you have 2 and 3, like, consider it to be neighbors of it, which you still need to consider. So you can form the number 1 2 3. If suppose you have considered 2, the option you have is that you can form the number 2 1 3. So that is where you need to backtrack from 1 to 2 and then consider the options of 1 and 3. This is again a graph problem that you find. So there is one more problem that I'll talk about. I won't take long on this and we can then move on to interview prep and Q&A. But this is a very interesting problem and I would say a simpler problem than the number of islands. So I'll just explain the problem. Let me know if you've not understood the problem definition. You have to find the letter combinations of a phone number. So for simplicity's sake, consider that your phone number is of 2 digit, be it 2 and 3. And you are asked to find the letter combinations that can be formed when you press 2 and 3. So here you are given 2 corresponds to A, B, and C. You remember the old keypads that we used to use. Once you press 2, A used to get printed. Twice you press 2, B used to get printed. So here the idea is that ABC corresponds to 2, DEF corresponds to 3, GHI corresponds to 4, and so on. So you have to find the letter combinations of a phone number. So if you are given the phone number 2 and 3, if you're given the phone number 2 and 3, the letter combinations possible are, consider A and D, A and E, A and F, B and D, B and E, B and F, C and D, C and E, C and F. Is the problem definition clear to you all? Like, you have to pick the first letter that corresponds to 2. You have to pick the first letter that corresponds to 3. That would make 23. Again, you can pick the first letter that corresponds to 2 and pick the second letter that corresponds to 3. That again represents 2 and 3. So you have AE. Is this definition kind of clear to you all, or anyone has doubt over it? Okay. So this is again like when the first letter possible when 2 is pressed is A, B, and C, and against it you have the letters that correspond to 3, that is D, E, and F. So you have these 9 combinations: A, D, A, E, A, F, B, D, B, B, F, and CD, CE, CF. So, why do you think this is a graph problem again? Or this can be solved using normal like permutations or by iterating over. You can like, don't you think you can simply solve it using um, consider A, then you iterate over all of this and you print out A, D, A, E, A, F first. Then you consider B, iterate over all of this, then you print out B, D, B, E, B, F next. Why do you think this is a graph problem? Anyone can, anyone, like any opinion why it would be better to solve it using graph? Okay, so maybe if you can see here that a graph can be made with the combinations that are possible. So A, D, A, E, A, F. This is one particular graph that can be made. You can it it is kind of a tree. Tree is again a graph which is not directed. So you have this first letter of two, first letter that corresponds to two, and all the letters that correspond to three. That would make your first three combinations. Then you have the second letter that corresponds to two, and all the letters that correspond to three. That will make your next three combinations. So this is how you can represent it with a graph. Like maybe you can consider A as the first node, and for the next digit you can consider the elements that correspond to this particular digit as its children node, as its neighbor nodes. So you can, so that is how your final answer prints out to be ADAF, BDBBF, CDCECF. So there are basically three into three, three into three possibilities for these two digits. So this is just another representation of graph that I've done for each of the this particular level. The ABC level corresponds to the first digit of our number, and this last level corresponds to the second digit of our number. So again, if you see, this is 3 into 3 problem. This is again a graph that is formed. You can consider this A as a node and these are its neighbor nodes, which you have to visit to form one combination. You have to visit D to form AD, you have to visit E to form AE, and so on. So, why do you think we would like anyone can attempt like why do we need backtracking or any kind of recursion here? Like any general idea you can give, we can just discuss over this. Like any vague idea you can give, why and how would we need, or if we would even need recursion or backtracking here to form the letters A D A E A F and so on. Anyone?
Like we are repeatedly moving from one node to another, like we are going from A to D, then we are again going from A to E. So we are like repeating the same thing. So for that we can use recursion.
Correct. Yeah. So yeah, you're right. We are doing the same thing again and again. Like we are moving to that particular node, checking its neighbor, printing out the combination. Again, we are going to that particular node, printing the next combination. So this going back again and doing the same thing. Again, this relates to recursion, and going back relates to backtracking. This this is why again this can be formed into a DFS recursion backtracking problem. So, in the interest of time, I'll just do a run over it, and maybe I can send you over the code, which is like, which is very simple. We can go through over it. Uh, so, so like you said, we are picking the first node. We are picking the first node A. Consider one of its neighbors, and we got our result as AD. Now that we are at D, what do we do? How do we go back to A? This is where backtracking comes into picture, and this is where recursion will also help us to do. Once we backtrack back to A, we'll again repeat the same thing that we did for AD. We'll again print out A. Once we backtrack back to A, we check out the next neighbor of it. Again, we do the same thing for A and F. Now that we have checked for all these particular neighbors and this particular node A and neighbors of A, how do we go back to B? Over here again, there's backtracking to be done. We go back to the level 0. We again backtrack to the starting point of our problem and check for the next letter that corresponds to our first digit. That was 2. 2 corresponds to ABC. We have already considered this node A and its neighbors. So we consider the next node, that is B. And we do the same thing for B and its neighbors and go on with C and its neighbors. So, so this is how this problem can be solved using 2 for loops, iterating over 2 string and printing out the result. But many a times in like coding interviews, you will have the need to optimize it. So this is where you'll have to think it in a way, is there a repetition? Can I use recursion here? Or do I have to go back to my previous node and do the same thing again? Okay, I can use backtracking here. So these were 2 problems that mainly signify uh, how problems that can be easily solved with graph and user concepts of recursion and backtracking.
Hi Simran, does this recursion and backtracking optimizes the time complexity rather than using the for loop, two for loops?
Yes, it does. So using 2 for loops will make your time complexity as O of n into n. If the size of your if the size of your string is n, uh, your our string was size of ABC, that was of size 3. So it would become O of 3 into 3. This increases the complexity, whereas any problem that you solve with graph, what you are left with is that number of edges plus the number of vertices. That is what your time complexity goes to. So your time complexity would be your number of edges, that is the edges that you're traversing. I think here there are 3 edges that you're traversing here, plus the number of nodes that you're considering. So it becomes O of number of vertices plus number of edges. That is because just like in loops, we are looping over each of the iteration. Here we are basically looping, or we maybe going through over the paths. That's why we call it our time complexity becomes number of paths, that is number of edges, plus the number of vertices that we are visiting. So it like really reduces down from a order of n square to just a linear number. So that is why we mostly prefer using graphs in some problems. Okay, so I think these were 2 problems that I mainly wanted to introduce you all to, and again, these 2 problems can be found on CodeChef and LeetCode both. You can try your hand at it. If needed, I can also send out the codes for it, so you can like refer it and that can act as a boilerplate for you. Uh, I think I'll go on to the next segment. We have just 15 minutes more left for placement and interview preparation. So here I would suggest you all to just unmute yourself and just tell me like what are your concerns or what are your questions regarding placement and interview preparation and how you are planning to approach it. If you have any doubts, you can just speak very freely to me regarding this.
Okay, so Simran, we did receive some of the queries while the registration.
Hmm.
So one of the most sought after question was if you could share your experience at GPMC and some tips and tricks along the way.
Okay, okay. So, so your experience, I would say your experience at uh, these financial institutions like JP Morgan Chase, Goldman Sachs, Barclays, Morgan Stanley, these would vary from team to team. And during our time, hiring, I would say during our time, hiring was fairly simpler than what it is now for you all. Because during our time, we had it through hackathon and not like now. Like, I think you all have online tests and then interviews and so on for it. During our time, we only had hackathons, and hackathon was your like entrant into JP Morgan. So, so that did not need any targeted preparation. That interview experience with GPMC because it was purely a hackathon related decision. And regarding my experience at GP, so what I mostly work on Java and React. I do full stack, but there are many teams which do only backend, and many teams which do only front end, and many teams which only also do just DB related work. You know, like SQL queries and stuff. So, like it would differ from team to team, and so for me, it was full stack, as in I have to work on both the back end and front end. And front end for me, React was very new when I entered there when I started. So, but all of this Java, React, and everything I learned on job only. I wouldn't say that I knew React beforehand or I knew Java because I think even you all right now, we in college try to use Python, C++ more, and but these companies prefer Java a lot. All the production code, all major products are all made in Java and frameworks like React. So that was initially it was a very steep learning curve for me, learning Java and React, and it was very fun also because you get to learn from very experienced people. Like everyone in my team was more than 7 years experienced, and that really helps, and that really they really give you advices which helps you like learn things faster and also in a very standard way possible, like the ideal programmatic way possible. um yeah, so that is mostly my experience in JP. Like, I work on user facing portals, and there is honestly there's a lot more to do, a lot like beside coding. There's a lot of interaction with business, understanding their requirements at like the starting of your development cycle, and after that you go on to the architecture design, and then finally go on to writing code. And even after having written your code, you have a lot of steps to do. Now that you have written the code, you have to deploy it, you have to test it. Testing is what you'll come across a lot when you join your companies. And yeah, that is pretty much my experience.
Okay, so I noticed that you mentioned hackathon. So many of us who are present here have put in our applications for Code for Good, and like if you could also share in some insights on that.
So okay, so Code for Good is even now I think it is a 24-hour long hackathon. The only difference is that it has become virtual now. So the main thing that helped me there was a lot of emphasis on teamwork because we had to pair up with people you don't know, you have not worked with before. So it was what really helped us uh, during that during that phase was that initially itself we had to like talk with each other, talk along with the teammates, just put forward our strengths that yes, I this is what I know, I can do front end well, I can maybe make a DB design well, I can write back end well, in which language. So this initial tech stack discussion and decision thing was took a lot of time for us, and this I think would happen for you all also. And but I would encourage that you all come to a common ground and pick pick up a tech stack which suits your strengths and is not something very low level also, because there were teams which had done like HTML pages and all that really doesn't make sense in a hackathon. So you need to have a whole functional app, even if your front end is like uh, not very pleasing to the eye, but if it is functional, they would consider it. That is what had happened with my team. Our front end was not really great, but our functionality was end to end. It wasn't breaking at any point. So so that is what they focus on. And teamwork, and also I would say like you should communicate with the mentors that join your calls and ask them doubts and like clarify requirements. You can even discuss the requirement and tell them, okay, this is I have this particular requirement, this is how we are planning to do it, what do you suggest, is this good? So that's a good way to put yourself forward to the mentor and also show that you're thinking and working as a team.
Yeah, yeah, definitely, definitely. Also, one of the questions that we received was the recommended skill sets that a student should know before applying for a company like JPMC.
Okay. So for GPMC, I would say specifically looks for Java developers. 80% it looks for Java developers, but there is work in Python too. And so I think you all really prefer Python. I We used to also do that in college. So it is good to know Python, but it is also very important to know the object-oriented concepts. Even if you don't know like Java through and through, the you know writing classes and the functions, how frameworks of Java work. Even if you don't know that, you should at least know the object-oriented programming concepts and everything. So that is what they focus on a lot. And apart from it, database related concepts and SQL queries. That is like very vastly used. It will be vastly used not just in JPMC, anywhere that you go. And I think they don't expect anything as such. You should know like in front end, but it's good to have familiarity with like how a website is built, how frameworks work. If like like during our time we used to do a lot of PHP, Laravel, Bootstrap and stuff. I think now it's mostly you should focus on React Angular frameworks because they're really interesting and more widely used in the industry.
Yes, definitely, definitely. Well, we will be focusing on that. I personally also am currently learning about React, so I'll be doing
Yeah,
that.
that would help. Yes.
Also, if we have any other questions from participants, please feel free to put it in the chat box.
So I would um, like until anyone else speaks up, I would say that if you're in case of your placement prep, the things that are shown on the screen right now, those like encompass everything that would that you would need for your preparation. And uh, and even if you are first years, you I would say that get yourself familiar with things like uh, things like algorithm data structure, because I have seen that companies right now really have rounds that only consist of algorithm data structure. They don't ask you anything about Java or maybe SQL or anything like that. So this is basically mostly banks that do that, like Amazon, Google, and all. So it would be good if you are familiar with it right from your first year. I don't know how the scene changes, like the placement scene changes for you all in the coming years, because even for me, I think it's been just 1.52 years, but I see vast difference in how the placements are happening right now. But yes, this Geeks for Geeks, Code Chef, Lead Code, you should be regular on it. Like,
We have a question on the chat box from Animesh. Says that is CP enough or knowing different technologies like AngularJS necessary?
so knowing just CP is not enough. Um, and different technologies, I would say, not specifically Angular JS, but you should know the JS of it. Like you should know JavaScript rather than knowing Angular JS, because all these frameworks, React, Angular, everything is built on JavaScript. If you know how JavaScript is written, what are the ideas in it, once you have picked up JavaScript, it will be very, very easy for you to pick up Angular. And to be honest, your interviewers should not ask you about React or Angular in interviews unless it's like a very specific requirement. But I have still not heard anyone being asked things on this. But yes, you'll be widely asked on CP, you'll be widely asked on object oriented programming, on operating system, on AlgoDS, and computer networks. These are things that they would ask you rather than specific technology questions. More like they'll ask you concepts and not technologies.
I hope that answers your question, Animesh.
Yes, yes. Thank you.
Okay. Another thing maybe I can say that I have noticed, um, even if like even if you are applying through your campus, but I would also encourage you to apply off campus as well, because I have seen that earlier, like when we used to apply through the company's career portals, we never really got a reply as such. Like it wasn't really looked at the career portal thing. Like that was like cold applying, you could call it. But I would say right now scene has changed. You should really try off campus companies too, and also apply to their career portals, because people do look at it. If even if um, even if you apply like in your seventh semester, maybe you don't get a reply immediately, but they might contact you within 6 months or a year, because they have your resume and your details into their database. So I would suggest, even if you don't get any replies, please do consider applying off campus to companies that you dream of. Also, that if they do not come to your campus, that if not immediately, down the line, maybe they might contact you. I have seen instances that this happens. So do that too.
Yeah,
Okay, like oh, okay, like so we should go to the career page and like apply it. Like we don't have to expect it like they would reply in 3 months or
Correct,
four
correct.
months. But we, and also like instead of knowing different technologies, like we should more focus on data structure, algorithm,
Yes,
design, system design, like those stuffs. Like
yes,
those are
yes.
asked
Mostly
deeply.
concepts. Yes.
Okay, okay. Thank you.
Any more questions or anything in general you would want to ask me about?
Simran, could you also share some of your hackathon experience, as in, like participating with a complete stranger altogether, and then like going ahead with hackathons. Today they are also happening virtually. So how should we go ahead with hackathons and build up our strategy?
Okay. So so in case of hackathons, I would say that it is difficult to work with someone you don't really know any like from before. You don't know how they work, or you don't know what things they know. So what really helped was that initially, like in the very beginning phase of hackathon, you should communicate very well with the person, and you should like obtain a common ground that okay, this is what we know, this is what you know, I know, and this is what we both know. Maybe let's pick up this tech stack and go forward with it. You should have very you should have very clear communication with each other, and I think in cases of hackathon, the other person also cooperates because it's a case where you both um, where that hackathon really matters to both of you. So you both have to do your best, and it is not a matter of what to choose. Like I don't want to do what this person is saying. Also, you really need to have a common ground and decide on some things, communicate well, and communicate at all phases, like throughout the hackathon. Like, this is what I am doing. What are you up to? Are we at the same page? Are we doing the same things? Uh, is this what we are expecting? Are we going in the right directions? All of that.
Okay, yes. Also, one of the questions that we have
Mhm.
received from the chat, how to manage both CP and
Manage both. Uh, yes. So that is actually very difficult. So what I would say is that Java framework, again, as I said, they don't expect you to know beforehand. They don't expect you to know React beforehand. But even if you have some experience, like some experience or some mentions on your resume that you have built a website, as assignments or as projects, you can put that, right? So even if you have experience in building application using say Python and React, that would still reflect that okay, you know UI concepts, you know backend concepts. So they don't really say that they don't really expect you to know Java framework and React, and but I would say that you should know how to explain the OOP concepts, and how that OOP concept translate into code, like in Java, how a class is made, how the parent-child relation between classes established to say like to exhibit inheritance, all of that. So that that basic Java coding, that basic OOP concepts you should know. You don't need to know frameworks or anything. So that leaves you with some time to like consider and prepare for CP and all the data structure algorithms. But what I have noticed is that there is a pattern to interview preparation. Like for example, if you are targeting companies like Amazon and so, or if you're targeting company like Morgan Stanley, they really focus on DS algo, and things like interview experiences on Geeks for Geeks really helps. If you go through the interview experiences, you will see a pattern that like for Amazon, I would say they ask a lot of trees. They ask a lot of dynamic programming. For Morgan Stanley, I would say they ask a lot of array related CP programs, like finding the longest subsequence, finding the maximum sub array with zero, all those things. Like a level below the sum set is asked by Amazon, but still, if you go through the experiences and the questions, the company specific questions on Geeks for Geeks or Lead Code, you'll find a pattern. And once you've figured out that pattern, I think it won't take long for you to learn CP specific to interview preparation. If you dedicate like 3 4 months or one whole semester to it and do it daily, like 1 or 2 hours, do daily problems like your heat map on code chef and lead code should show green every day. So that would once you figure out the pattern and you know what problems you need to target, it would be much easier to manage your time that way rather than um, going and solving each and every problem out there. You need to like I'll suggest one YouTube tutorial. Uh, so this particular I just write down in the chat. Penny talks code. So this particular person, he has a YouTube playlist, uh, which which is the videos are divided into topics like graph, trees, and the thing that we saw today, DFS. So what he does is he picks 2 3 problems related to it, and he shows that these 3 problems, this is how they are related, and you really see that okay, the same code with minor tweaks here and there really solves the same problems. So that is how you need to do like targeted where you pick up one topic, you solve um, 10 to 12 problems on the same concept. That is how you'll also retain it. Like you'll also understand it through and through that okay, these 10 problems were really similar. This is the code structure that is there. Okay, this was a concept. This particular concept was behind these 10 problems. So any problem, the 11th problem that you see which is similar to 10 problems, you'll really be able to solve. So this particular person's playlist has really good, like he solves 1 or 2 problems and he tells you that these are other related ones. I think that section is also shown on Lead Code and Code Chef. Like once you have solved the problem, other related. So you should really go and um, I think this way you can the target and manage CP, like do a target based rather than trying to solve everything out there.
Like Simran, if we want to get a good hands on and if we practice daily, so like on an means case basis, like how much time it will require to like be confident and solve interview problems like those.
Um, Actually, it is difficult to be confident even half an hour before the interview. You really are scared until the end of it because you really you can't say what would be thrown at you, what problem would be thrown at you, and it is I would say be confident that you can be confident and sure that even if there's an unexpected problem, you will be able to tackle it. That is what you need to target, like, and how much time it would take. I would say if I were in college and if I had to look back and say I should have given like 6 months of dedicated prep to these kind of DSRGO problems. So for me to like really be sure of it and not be afraid to give an even an unfamiliar problem in the interview.
Okay, like 2 to 3 hours of daily solving for 6 to 7 months will means give a good
Good
knowledge.
hand on it, yes, yes.
Okay, thank you.
Simran, this is Mayani Agnihotri. I'm a first year engineering student. So can I know more about how often you keep such kind of meetings and like different topics you cover and like what's the purpose from your side? Because I got to know about this through LinkedIn. That's why.
Okay. Uh, no, I think this is my first time attempting something like this. So, and actually, even me in college, I had not ventured a lot in CP and stuff. I had, but the company that came to our campus really didn't test us on that. But once I was placed in JP, I got a chance to interview with Goldman Sachs. So while prepping for that and for that, I really understood that the CP and the importance of CP and DSR good related problems. Um, so many, I don't really hold sessions as such, but if you want to talk more about it, like interview prep or something, you can directly ask me, chat with me on LinkedIn because past few months even I have been into interviews. So that is why I Anika and Legana, when they contacted me to take up this lecture, I thought I am fresh with all these concepts, so maybe I can give it a shot. So any doubt, anytime you can just ping me on LinkedIn, and I'll be happy to discuss. Many or anyone else, like I'll be happy to help you with any interview prep, any resources, anything good that I find, I can send it to you. Or any doubt if you have, what kind of books you should refer, what kind of YouTube tutorials that you can refer, what problems to solve. I I'm more than happy to discuss about it.
That is so good to hear, Simran. And you know, like we are also in our third year almost. Our year is almost completed, so we are
Yeah,
also up for our placements.
okay.
We'll definitely ask you
It's
if I did.
intimidating, but all the best.
Thank you so much. We really needed it.
All the best to all of you too. Like even if you're first year, you have a long way to go, and but it's fun also. So all the best.
Anika, you are on mute.
Oh, sorry. I was speaking on mute. Um, do we have any more doubts? All right. I think we don't have any more doubts.
Okay.
We can wrap up the session. First of all, thank you so much, Simran, today. Learned a lot from today's session. It was quite informative and insightful, especially the visualization and everything, you know, like everything got crystal clear. I'm sure the participants have a lot to take in from today's session. Thank you so very much. It was a pleasure to have you with us.
Thank you, and it was really nice to talk to you all. And any help or anything you want to discuss about, please chat with me on LinkedIn. If you also Anika, if you want me to send forward any codes or any resources or any links, I can I can share it to you and you can forward it up to all the participants.
Um, Thank you, Anita. Thank you, Simran, for
Thank
Thank
you.
this great
you.
session.
Thank you for joining in.
Thanks all. Bye bye.